In our section 3.3, we're going to work on parallel lines still, but we're going to add some proofs to the mix. And the first thing that we're going to talk about is the converse of corresponding angles. So we know that if parallel lines, then we can say we have corresponding angles. Well, the converse says that if we can have corresponding angles, so if we have those angles that are congruent, then now we can prove parallel lines. So that's one of the ways that we're going to do that. The next thing that we're going to do is construct. We're going to construct some parallel lines. So you're going to draw a line, just a little line segment, and a point. And what you're going to do with that is you're going to then connect. So any way that you want, you're going to connect your point with your line. And then you're going to take your compass and you're going to place it on this vertex here. And I'm going to adjust this so it's not super huge. And I'm going to make myself a little arc. I'm going to pick it up and I'm going to do the same thing at the point that I made. I'm going to make this little arc. Then I'm going to copy an angle. So remember that we copied these angles before we did this. I'm going to take and I'm going to put my point right here on that line. And then I'm going to adjust my compass until I can measure exactly what this angle measure is. And then I'm going to give it a little swing. And I'm going to pick it up and I'm going to take that exact same measurement and I'm going to copy it over here. So I'm going to put that right on the vertex. And again, I'm going to give it, whoops, slipped. I'm going to give it a little swing so it makes that little arc. And that little X marks the spot is what I'm looking for. That little X marks the spot and my point, or what I can connect, and then I can say that those two lines are parallel. The next piece that we're going to look at in our section 3 is another converse theorem. And sorry, I got all kind of crazy with my writing here. But in theorem 3.6, we're talking about alternate interior. Alternate interior angles, again, work the same. So the converse is saying that if we have alternate interior angles, then I can prove parallel. In 3.7, it's the alternate exterior converse. So again, I have alternate exterior angles, and if I have alternate exterior angles, then I can say they are parallel. Remember before when we did this, it was just flipped around. It was the converse. We said if we have parallel lines, then we have alternate exterior. And now we're just flip-flopping that around. The next theorem in theorem 3.8 talks about consecutive interior. Remember those consecutive interior, we kind of made like a little U or like a little hook with our highlighter. And again, we're saying that if we have consecutive interior angles that add to be 180 degrees, then I can also say that they are parallel lines. And the last piece of this here, I'll try to make this a little bit bigger so you can see, is theorem 3.9, and it's talking about the transitive property of parallel lines. And it says that if two lines are parallel to the same line, then they're all parallel to each other. So they're saying, for instance, if 1 and 2 are parallel to each other, and then we're saying that 2 and 3 are parallel to each other, well then I know that 1 and 3 would also be parallel, that they would all be parallel. If I can say that these two are and these two are, then they're all going to be parallel to each other.